Good morning. I'll try to wake you up with this subject. I have 30 minutes. I think 15 minutes I'm going to talk, and then 15 minutes I'll expect your questions. I'm sure you will have some. I'll try to show you why I think continuous integration doesn't work as it should work. That is more for the title to get your attention. And then I'll show you how we can make it alive again, how we can make it work as it's supposed to work. So continuous integration, I'm sure most of you understand what it is, but I'll just briefly explain it again. So continuous integration, when a few people or a group of people, a group of programmers is writing some code and committing this code to the master branch. Let's say we have Git or some version control system. We have a continuous integration server which after each commit to master branch, it gets the code from the master branch. It tries to build the entire project, and then if it succeeds, it gives us the green light. If it fails, we get a red light. So that's basically the idea of continuous integration. So if it doesn't work, if something is broken, if some of the unit tests are broken or it's just not buildable anymore, we get the red flag, and then we're supposed to do something about it. There's a famous book about continuous delivery, and Jez Humble says, I quote, that crucially, if the build fails, you can read it, the development team stops whatever they're doing and fixes the problem immediately. So once again, if something goes wrong, if I'm a developer, I commit something to the master branch, and then after that, the continuous integration server, for example, Jenkins or a Travis, which is a service, not a server, or there are many of them on the market, you get a red flag. It means that the whole team, all of these people, have to stop and do something about it. This is really crucial for continuous integration. Why it's important? Because if it's broken, then we basically cannot continue to develop anything, because the master branch is broken, which means that I don't know whether my next commit is going to break it more or it was broken again. So we need to get it back to the green state. And now there's the problem. The problem is that it's not actually happening in reality, because basically in a real team, in a real situation, there's nobody who actually needs this. There's nobody who actually needs to stop the development, to put everybody on hold and fix the master branch. Because this may be needed if there's one developer, maybe two developers. But if team is bigger and we have the product owner who wants us to deliver new features, or we have the architect who wants us to continue the development, or we have the CEO of the company who also wants us to continue the development. So nobody, including the author of the commit, which actually broke the master branch, and including other developers, nobody actually needs and wants the whole team to stop. We want to continue. We don't want to put on hold the entire project and fix some continuous integration server which gave some red flag somewhere on the screen. So we just don't want that. We just don't need that. That's the reality. That's what's happening. And basically, and then we just have two options how to fix that. The option number one is that we just ignore it. Just ignore it. This is what's happening in the majority of companies and teams I've seen so far. Just ignore it. And what you have then, if you ignore it, you have the green flag and red flag sometimes. Green flag, red flag. And then it goes to red, 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 and then it keeps staying red until somebody on some weekend, some superhero in the team will fix it and it's green again. But in most cases, it's going to be red, and everybody will just ignore the continuous integration server and not pay attention to it. That's the first option, what I've seen so far in 90% of cases. Option number two is enforce it. So the first option is ignore it. The second one is enforce it. Enforce it means that we have a discipline, so we are organized people, we're disciplined people. Let's just, enforce it and say that if the flag is red, we have to stop, really, like the book recommends. We have to stop and we have to fix the master branch. What does it mean in reality? How does it happen? That's what I've seen. First of all, it's the situation of blame. So who broke the master branch? It's a team of 5 people. Okay, who did that? You did that. Okay, first of all, we need to find out who is the guilty one. Who did that? The second one, if we do that, for the discipline, we need to do that. We can't just ignore who actually broke that. We start sort of finger pointing. The second one is the fear. So the person who everybody starts to fear to break, starts to be afraid of breaking master branch. You just don't want to break the master branch because you don't want to be blamed. So I'm, as a developer, I'm going to try to stay away from any critical changes. I'm going to try to stay away from any possibility of breaking stuff, of breaking some unit tests. So it creates the fear in the team. So I'm afraid to break things. If I'm afraid to break things, then I'm going to work on longer branches. So I start a branch where I make the changes, and I will try to make my branch as perfect as possible before I put it back to master branch. So it just creates, I'm just afraid to put whatever I want into master branch because I will break it and they will blame me. Well, the whole team will blame me. And then if we have longer branches, then we're going to eventually start throwing away some branches. Because if I start coding something in a branch, it takes too long. In a day, I can still merge it back. In 5 days, the possibility to put my code back into master branch while 5 more people are working with the same code is getting lower. So I basically cannot put it back anymore without merge conflicts. So I will eventually have throwaway code, which is not possible to put anyhow to the master branch. And I will just throw it away. Throwaway means losses. So we basically have people working on branches for too long and then just throw away the entire code and say, you know what, it's not mergeable anymore. I'm working for a week on this stuff. I'm trying to make it perfect, while other 3 or 5 people just putting some garbage in there. I can't do anything more. I'll just throw it away and start from scratch. Again, I've seen these situations many times. So this is the option number 2. So the option number 1 is ignore it. The option number 2 is enforce it. In both cases, we'll lose. In both cases, continuous integration actually doesn't work, and it causes damages to the whole team. Because in case of ignore it, it's just waste of resources and time, which we put to install this server, to keep it running, to pay attention to these flags and everything. In case of enforce it, we basically damage the team because we have losses. We have people working on something which is not needed anymore. So that's why I'm saying that continuous integration is dead, because that's what I've experienced on practical projects and practical teams. They just cannot use continuous integration as something which gives value to the company, because they either ignore these flags, this Jenkins, they install the Jenkins, they configure the server, but they don't know what to do with these flags, because they just can't spend time on stopping, and holding the whole team and just waiting while somebody will fix the master branch. Or they try to enforce, and then they have this situation with really branches which are too long and too big, and nobody can do anything about them. So here's the solution. That's what I think is a solution. It's called Preflight builds. It's not invented by me. It's you can see it in a few continuous integration systems, and it's a good thing. And very few companies, very few teams are using that. And what I'm suggesting is to try that and go for it, because this is the way to put continuous integration back into life. The Preflight builds mean that we do not allow anymore anybody to put the stuff, anything, to master branch. So we don't allow programmers, none of us, can actually put anything into master directly. So the master branch is completely, the security rules are configured so that nobody can push anything into master. If you want to put something into master, you prepare your branch, and then you give your branch to the Preflight bot, some server, some machine, which tries to get your code, merge it with master, and run the full build before the continuous integration server. So we run the build once on a Preflight step, and then only the bot can merge the stuff into master. So no human, no person, no programmer can merge into master manually. Only the bot can do that. And then when the bot puts the stuff into master, then the master is, in most cases, will be clean. In 95, 99% it will be clean. Because I cannot simply break the master if I'm a programmer. I cannot break it. I cannot put my stuff in there which breaks the unit testing, which violates something, which makes the build unpackageable, unbuildable. So this Preflight build is the solution for continuous integration. In this case, the continuous integration server will, in most cases, give the green signal. It's not going to show the red signal anymore, the red flag. It's going to be green in most cases, if nobody can actually put stuff directly to master. So we kind of protect master against us, against programmers. So the life of programmers becomes more difficult, because now they need to, every time they create something, they need to pass the control, pass this mechanism of Preflight build. So they need to pass this quality guard. before they can actually put something in the master. So the life of programmers is becoming a little bit more complex, a little bit more difficult, so the less flexibility. You cannot just freely push something to master and continue to do something else. You need to wait for this pre-flight bot to get your stuff together and merge it there. But it makes the whole situation in the project way better and more effective. And this is almost the last slide. So I created this tool. I'm not going to promote it. I'm just saying that how I've done it for my project. So I've created this tool which is called Rulter. It's an open source hosted microservice, which actually is the pre-flight bot. So it works on GitHub. So you just in GitHub you have pull requests, and in any pull request you can just give an instruction to Rulter and say, this is my pull request. How about you get this code, merge it into master, try to merge it with master, build it, and push it to master. And it does, and in order to achieve this idea of restriction for the master, we make the master branch read-only for everybody in GitHub. So we don't give access for the push. We don't give write access to any programmers there, and we use only pull requests in our projects, in open source projects as well. And this is the last one. So this is what we've achieved so far. That's what we've experienced. The first of all is that 95% of our builds are clean. So we don't have red flag, green flag, red flag, green flag. We have 95% situations it's green, which is really something which we wanted to achieve. The second one, we don't have any fear anymore of breaking master. Because people know that, all the developers know that no matter how bad is my code, no matter how bad is my branch, it's not going to go into master unless it passes all the unit tests, and all this packaging will happen successfully. So I don't need to be afraid of what's happening, what's going to happen after I code in my branch and put it in the master. Because in most cases, it's just not going to go through, and it will be returned to me before anybody else can see it in master. So I don't have a fear, which is good for development. So developers can develop faster, can develop without fear, which is really an achievement. The second one the third one is that we don't have any blame, no stress. So we don't blame programmers for breaking master, because we know that if somebody breaks something in the mainstream of development, in the master branch, it means that our pre-flight check is not strong enough. So we don't put the blame to programmer, we put the blame on the bot and say, probably we don't control it properly if some code actually managed to go through. So we don't blame programmers, we blame the script, which is also good for the environment, for the culture of development. And number 4 is that we have quick and small branches, which is also an achievement. So programmers can work in small branches because they don't have fear, so they don't need to wait for too long and make their code perfect. They just do something, make some small changes, push it to master, it goes through the pre-flight build, there is success, boom, it's in master. So that's what we've managed to achieve using these pre-flight builds. This idea of pre-flight builds exists as far as I know, in like 3 or maybe about 2 or 3 continuous integration servers. I think in TeamCity it exists, but I'm not like 100% sure. But I created this tool a year ago, yeah, and it's been successfully used by over 200 open source projects right now. You can try it yourself. What do you think?
We have questions? Okay.
Hi, thank you for a nice presentation. I generally agree with the idea, but maybe I didn't understand everything. What's the difference between this solution and just setting like Jenkins jobs that for every commit you run a bunch of tests, be it like a syntax test, unit test, or even some build or deployment tests, and then make those jobs voting simply, and only allow merges or even merge automatically if you get +1 votes from your CI. So without any additional tool, you just set Jenkins jobs that checks your commits basically and allow merges only if this code passes some tests of yours. For example, entire OpenStack.org CI works this way, which is a large project.
Yeah, the main concern here, I think I understand the question. So the main problem with that is, no matter how you configure your CI server, if you allow, the key thing here is that you do not allow programmers to put anything into master. Because as soon as the code gets into master, it's too late. It's just too late. If everything, whatever you configure afterwards, but if I am as a programmer can technically put my code into master and go home, then no matter what happens afterwards in Jenkins, in any server, in any script, it's just too late because it's really difficult to get it back and the development continues. So if you mean that you configure, if you don't use any tools, but you configure something which will actually prevent me from pushing to master, then it's fine. Then this is what I mean. But I'm saying that these pre-flight builds, they should go together with protecting master branch. So the master branch should not be available, should be read-only. That's important, that's critical. So that nobody can put anything there. That anything you want to put there goes through the machine, goes through this pre-flight bot. That's the key thing. So it doesn't happen afterwards. Everything should happen before, pre-flight, before the flight. That's my, or I didn't understand the question.
Well, I think if you allow guys to put things to master without actually going through CI first, it doesn't look like CI to me, because CI should take care of your code before you actually allow to merge it. This is how I understand CI. Because otherwise,
no, traditional understanding of continuous integration is this. This is like by the book. So this is what CI is. So the continuous integration happens after the merge. So we put stuff in there, we put it there, and then eventually we merge and see what's going on. So this is what the book says. So if the build fails, then the development team stops whatever they're doing, so fixes the problem immediately. So we're checking the build afterwards. That's the idea of continuous integration.
I haven't read the book. Well, the way we do this is we have simply Jenkins jobs, and yes, master is you're not allowed to push to master, and you have a voting system. For example, Gerrit, that you can have votes from CI jobs or from people, and if you get enough points from those votes, then the merge can happen automatically, or you can do it manually. That's
exactly what I'm talking. So you're doing exactly what I'm explaining. So
well,
yes.
not only me. I think many projects are done this way.
I haven't seen many. In most cases, people don't have that.
Okay.
So if you look at this open source projects on GitHub, many of them, they use Travis, for example, and they just configure Travis, and they make the master branch available for all developers, all contributors, and that's it. So the case you explained with Gerrit, which is the tool similar to what I explained, it's exactly how it should be. That's what I'm saying. So you're right, yes, you're doing it right. But not so many people are doing that. Not so many, unfortunately. So traditionally, the continuous integration is something which happens afterwards. So we just put stuff in there, all the garbage, everything, and then eventually it builds. But in most cases, it doesn't. So that's the reality. That's why it's dead. And it's not just bad that I see these red flags. This is not the key problem. But the problem is that we have this. So if we try to enforce it, that's where the continuous integration actually starts damaging us. It's not just if we just ignore it, it's not a big deal. We just ignore it. It's some red flag staying somewhere. It's okay. It's not a big problem. We just configure the continuous CI server. We just spend some money. Okay. But in this case, if we try to enforce it and tell everybody, like, you know what? If the build, like for example, I read this story from Microsoft that they're saying that whoever breaks the build has to wear some funny hat or has to go on overtime and fix this build. This is not just Microsoft. Many companies are saying that. This is the blame culture. So if somebody breaks the build, we're going to blame you, and then you're going to work overtime to fix that. This blame culture leads to bigger problems, way bigger than just ignoring it. Because it creates tension, it creates stress, it creates long branches, and then it's a lot of losses because throwaway code is in place.
Okay, we have another question.
Hello, thanks. Sorry, I have more of a remark maybe than question, but what strikes me from what we are discussing now is that the solution that you've developed and described is actually a technology-based way to work around the problem that you're showing on the slide right now. Now, the observation or question I would have is this. Why is it not viable for the agile delivery organization to really work into more generous culture to really overcome the blame, fear, and all these funny hats that you described? Wouldn't it be in the long run better to work on this rather than put a tool and create a perception in the organization that, right, in case we go bad, we can still develop another tool that will solve your problem in a short term and you will feel better for that. You know, you see the long-term value versus really a neat and probably very good tool that will solve your problem here and now, but maybe less of a long-lasting solution for future projects.
It's a good comment. It's a good comment. I totally agree with what you're saying, that this is organizational problem or maybe psychological problem, which I'm suggesting to solve by a technical solution. That's exactly what's happening. And this is the only thing, this is the only solution I found so far. So I didn't manage to find any organizational or management solution to this problem. So I just don't know how to remove this blame and fear from the, I tried in 5 different teams and 5 different companies in 3 different countries. And the same situations happen again and again. So I just think that this management problem is unsolvable because this is like natural for people to be afraid to be blamed. And this is natural for us to blame somebody who breaks something. So it's just inevitable. If we have a group of 10 people working together and then one person keeps breaking something, we're going to blame this person, no matter what. No matter how agile and no matter how highly educated or polite we are. It's just going to happen. And if we start blaming for breaking things, then everybody will start being afraid of breaking things. And this is really what was mentioned. The organizational situation, the management problem becomes unsolvable without the technical solution. So yes, this is exactly what's happening. The question behind you.
Okay. You are talking a lot about the blame, but isn't it more about responsibility for what we are doing? So you know that I'm responsible for what I'm doing, and I should solve it. And if somebody is able to show it to me that it's my fault, it's just responsibility and not blaming somebody.
Yeah,
we very fast and easily move into the blame thing. It's more about the responsibility for what you are doing.
Yeah, good comment. Yeah, definitely. I'm using the word blame, which is a stronger variant of the responsibility word. So I can cross the blame here and put responsibility. But in my experience, responsibility quite soon turns into blame. So it's if somebody is responsible, if we are responsible for our actions, then basically it means that there is some punishment in case we do something wrong, and the punishment means basically, well, sort of blame. Even in Git we have this git blame command. So we want to know who did that. That's going to be the question. Maybe let's not call it blame immediately. So we're not going to like point fingers on the first day. But first of all, we're going to ask, like, I've seen this many times. Probably you did. You also saw that. Like there's in the office, like somebody screaming, like again it's broken. Who did that? And then you look at the Git log. Yeah, I found it's Michael. It's you again. I've heard it many times in the office. And then this poor Michael is like, hello, I'm just trying to hide somewhere in the bathroom. So this is, yeah, that's what's happening. And this is, we can call it responsibility, but in reality it's sort of blame.
You know, if it's again Michael and again Michael and again Michael, you've got a bigger problem with Michael, you know.
Yeah. Exactly, yeah, exactly. So, of course, that's what I wanted to say. So if all the programmers are like really good programmers and they really check all the builds locally before pushing to master, if everything works like perfectly and you're dealing with a group of really responsible senior developers, then probably this problem will not be as obvious. But in most teams, we have senior and junior and different programmers, and some people are less responsible. So eventually, you will start pointing fingers and saying this Michael is actually breaking things again and again. Let's do something about him. And that will create fear. So nobody wants to become another Michael. So people will start to stay away from the master branch as far as possible. So, which means develop less code, which means make less changes, which means that the code will start freezing. And eventually you will have, like I said, long branches, waiting for too long, the code is not actually volatile. So it's only bad for development culture. I think so.
Any more questions, comments?
Why not just revert the last commit that goes the job?
Yeah,
to
that's a good option if the team is small. Yeah, I've seen that too. So we push something to master. If it doesn't work, the CI server says it's bad. We just revert. We just roll back, revert the last commit, and continue. Which is okay if the team is 3-5 people, maybe even less, and the development is not intensive. But if there is 25 people working intensively on the code, then you break the build, and then you have like 5 more commits in the master branch, and then you realize that something is broken, and then you're trying to roll it back, but that's too late. So you will have to do, in order to do the revert, you will spend a lot of time to just, first of all, you will have to stop everybody else and say, guys, you cannot trust master anymore. This is also a question of trust. So how can I, as a developer, check out the master branch, pull from master, and then create something if I run the build and it breaks? I just got the code from master. I run the build, it breaks. So how can I put something more in there if it's already broken? So I will start asking everybody around, like, what's going on with master? Can you fix that? So everybody will basically set on hold for some time. And the more people in the team we have, the longer will be this hold. So if there is 25 people, we can wait for a day or two, and everybody will start complaining and saying, let's just forget about this CI. Because we can't keep 25 people on hold. This is just unrealistic. The guy on the left down corner will come to you and say, like, you know what? I'm paying you guys a lot of money for delivering features, and you're sitting and fixing something in some master branch. I don't even understand what it is. Some CI server. Why did you even install this? I need features from you. I don't need this CI server. And you will really have a hard time explaining these people, like senior level people, what this CI is for, like why it's there, why money are spent on fixing some red flag in some CI server when the CEO or the product owner is expecting new features from you. So eventually they will just ask you, you know what, how about you pay less attention to the CI server and more attention to new features? Just, for some time. And you will say, okay, yes, what else can you say? And then eventually this ignore situation will be the status quo in the team. You will just keep ignoring it. That's what I've seen again. So it's just really difficult to explain to senior level people why we're on hold for a day, the entire team. Everybody's just sitting and waiting for like a few people fixing master branch because something is broken and nobody understands what actually is broken. I think we have time for maybe one more question. Or maybe not.
For a short one, or we'll leave the comments for the backstage.
Over there.
Okay, there's one more question.
Hi, thank you for the speech. And I have a question. How is your tool compatible with a more generic approach when a pull request is being reviewed by someone, by a supervisor, for example, or a group of reviewers? Because in many projects, this approach is used to ensure that not all tests passes, but the code quality is kept high.
The code review is something which happens before, normally it should happen before unit testing, before this pre-flight build. So in our case, in our projects, we do code review before we even start the pre-flight builds. So code review definitely is an important component of quality, but unit testing is something different. So technical packaging of the project, of the product, and reviewing the code for the quality, it's just two different steps. So when you do code review, you basically pay attention to the architecture, you pay attention to the design of this code, but you don't pay attention to whether this unit test is going to break or it's going to pass, because you basically you can't do it on just looking at the code. Only the compiler and then the actual build can give you this information. So we use code reviews. We do code reviews before passing these builds, before passing our pull requests to pre-flight builds. Yes, we do that.
Okay, thank you for the answer.
Can we leave that for the backstage? Sorry, because we're running out of time.
Yeah, sorry, we're running out of time. Thank you very much.
Seems like the topic is pretty controversial.